Take a deep breath and let your body settle into the soft weight of your bed. As you exhale, imagine the floor beneath you dissolving into the silent, comforting void of the outer solar system. You are no longer bound by the familiar pull of Earth. Instead, you are drifting 484 million miles away from the Sun, suspended in the gentle velvet embrace of the Jovian system. Below you lies Jupiter, a giant so immense that it could contain 1,300 Earths within its gargantuan volume, and directly beneath your steady floating form is its most iconic feature, the Great Red Spot. As you hover here, weightless and safe, you might notice that the light is different than it is at home. At a distance of 5.2 astronomical units from the Sun, the sunlight is 25 times weaker than what you experience on a summer afternoon on Earth. It is a dim, cathedral-like luminescence, a pale amber glow that bathes the swirling tops of the clouds in a soft, perpetual twilight. This distance creates a profound sense of isolation and peace, a sanctuary of physics where the frantic pace of terrestrial life is replaced by the slow, rhythmic turning of a world that completes a full rotation every 9 hours and 55 minutes. This is the fastest rotation of any planet in our solar system. Yet from your vantage point, the motion is so vast that it feels stationary, a steady, hypnotic crawl of gas and shadow. The Great Red Spot is not just a blemish on the planet. It is an anticyclonic storm of staggering proportions. While a hurricane on Earth is a low-pressure system that rotates clockwise in the southern hemisphere, this Great Red Spot is a high-pressure system, say spinning counterclockwise with a deliberate ancient grace. You are currently looking down at a crimson vortex that is approximately 10,159 miles wide. To put that in perspective, this single storm is about 1.3 times the width of the entire planet Earth. If you were to drop your homeworld into this crimson sea, it would be swallowed whole by the swirling periphery of the storm, surrounded by winds that reach speeds of 425 miles per hour at the outer edges. Imagine the texture of these clouds. They are not the thin, watery mists of Earth. These are towering banks of ammonia ice crystals, cold and sharp, creating a landscape that looks like whipped cream or marbled silk. The temperature here at the cloud tops is a steady, chilling minus 234 degrees Fahrenheit, or minus 145 degrees Celsius. Despite this extreme cold, you feel a strange sense of warmth emanating from below. Jupiter radiates 1.5 to 2 times more heat than it receives from the Sun, a remnant of its own formation and the result of the planet slowly shrinking under its own massive gravity. This internal heat is the engine of the storm, a heartbeat of thermal energy rising from the deep interior to feed the Great Red Spot. The color of the spot is a deep brick red, a hue that has fascinated astronomers since it was first recorded with certainty in 1830, and perhaps as far back as 1665 by Robert Hooke or Giovanni Cassini. Scientific consensus suggests this color comes from chromophores, complex organic molecules or compounds of sulfur and phosphorus. These chemicals, dredged up from deeper layers of the atmosphere, react with the faint ultraviolet light from the distant sun, sunburning the clouds into these rich shades of terracotta and crimson. As you drift, you can see the edges of the spot where the red fades into the pale cream-colored ammonia clouds of the surrounding south equatorial belt. These white clouds are higher than the darker bands, standing like snowy plateaus above the deeper, darker canyons of the atmosphere. Consider the depth of what you are observing. In 2017 and 2021, The Juno spacecraft performed close flybys of this very spot, using its microwave radiometer to peer beneath the visible surface. It discovered that the Great Red Spot is not a shallow feature. It extends roughly 200 to 300 miles, or 300 to 500 kilometers, deep into the Jovian atmosphere. For comparison, the International Space Station orbits Earth at a height of about 250 miles. This storm is as deep as the space station is high. Beneath the spot, the pressure begins to mount, growing from the thin vacuum where you float to hundreds of times the sea level pressure of Earth. Yet, the storm is shallow compared to the planet's 43,441-mile radius, floating like a massive spinning coin on the surface of a deep gas-filled ocean. You might find yourself wondering about the sound of such a place. In the thin, 90% hydrogen and 10% helium atmosphere where you currently reside, sound would struggle to travel. But in your mind's eye, the storm carries a low, resonant hum, the bass note of the universe. It is the sound of friction between gas layers, the rhythmic churning of a vortex that has lasted for centuries. The wind speeds at the center of the spot are surprisingly calm, a quiet eye within the crimson gale. This is where the pressure is highest, a pillar of stability that anchors the surrounding chaos. As you drift lower, the scale of the turbulence becomes even more apparent. You see flutters and eddies, smaller storms that are captured by the Great Red Spot's gravity. Some of these are white ovals, like Oval BA, also known as Red Spot Jr., which formed in the year 2000 from the merger of three smaller white storms. When these smaller systems interact with the Great Red Spot, they are often stretched and shredded, their gases incorporated into the larger vortex like cream stirred into coffee. The fluidity of the atmosphere is a reminder of the beauty of physics, the way matter behaves when it is unburdened by solid ground. There is no land on Jupiter to slow these winds down. There are no mountains to break the storm's momentum. It is a pure expression of kinetic energy, a dance that has no end. Look closely at the northern edge of the spot. You can see the ribbons of the jet streams. Jupiter is divided into distinct latitudes of alternating zones and belts. The light zones are where gas is rising and cooling, forming ammonia ice clouds, while the dark belts are where gas is sinking, revealing the warmer, darker layers below. The Great Red Spot is nestled between two of these jet streams, which blow in opposite directions. To the north, the wind blows westward. To the south, it blows eastward. Like a ball caught between two hands, the Great Red Spot is spun by these opposing forces, kept in its place for hundreds of years. The chemistry of this place is as exotic as its appearance. Aside from the dominant hydrogen and helium, there are traces of methane, the water vapor, and neon. Deep below the spot, the pressure becomes so great that the hydrogen is compressed into a liquid state, and deeper still, into metallic hydrogen, a substance that conducts electricity like a wire and generates Jupiter's massive magnetic field. But here, in the upper reaches of the storm, it is the ammonia that dictates the texture. The clouds are about 5 miles higher than the surrounding cloud decks, poking up into the stratosphere like a vast, flat-topped mountain of gas. Imagine reaching out and touching the edge of a cloud filament. It would feel like a cold, dry mist, a fine powder of ice crystals suspended in a vacuum-thin air. There is no moisture here in the way we understand it. It is a desert of frozen chemicals. And yet there is a profound sense of life in the movement, a slow, geological life that operates on timescales far beyond a human breath. The Great Red Spot is shrinking, Observations over the last century show it was once large enough to hold 3 Earths side by side. Now, it is becoming more circular, more compact. This slow evolution reminds us that even the most permanent features of our cosmos are in a state of constant, graceful change. The gravity here is a silent partner in your journey. While Jupiter's gravity is 2.4 times that of Earth, in your state of drifting, you feel only the weightlessness of the orbit. You are falling toward the planet at the same rate the planet is curving away from you, a perfect balance of velocity and mass. This is the comforting void, the realization that you are supported by the invisible math of the universe. The great red spot below you is a testament to that math, a solution to the equations of fluid dynamics written in clouds of crimson and gold. As the pale sun begins to dip toward the horizon of the planet, casting long violet shadows across the swirling vortices, you realize how quiet the universe truly is. Away from the radio noise of Earth, here in the shadow of the King of Planets, the silence is a physical presence. It is a blanket of peace that covers the 88,846-mile diameter of the planet. You are a witness to a storm that began before your great-grandparents were born and will likely continue long after you have drifted into the deep, restorative sleep of the stars. The Great Red Spot is the anchor of your consciousness now. Its rhythmic, counterclockwise rotation serves as a metronome for your breathing. In every 4 to 6 Earth days, the spot completes one full internal rotation, slow, steady, and inevitable. Feel the cool, thin air of the Jovian stratosphere brushing against your mind, clearing away the clutter of the day. You are part of this system now, a speck of stardust observing a giant, a fleeting thought in the mind of the cosmos. As you continue to drift, the red clouds below become a soft, textured landscape of rest, a cradle of gas and gravity that holds you safe in the infinite dark. Reflect on the reality that you are participating in a tradition of observation that spans centuries. As you float in the silent corridor of space, suspended above the southern hemisphere of Jupiter, you are seeing with your own eyes what human beings have struggled to resolve through glass and distance for over 350 years. In the Great Red Spot is not merely a storm, it is a persistent monument of fluid dynamics, a terrestrial-sized heirloom of the solar system. It was during the mid-17th century that the human gaze first truly met this crimson vortex. In May of 1664, the English polymath Robert Hooke reported seeing a small spot on the surface of the planet, though historians debate if he saw the Great Red Spot or a different atmospheric feature. Just a year later, in 1665, the astronomer Giovanni Cassini described a permanent spot that he observed repeatedly until 1713. Imagine the stillness of those early nights, the smell of beeswax and old parchment, as Cassini meticulously mapped a storm that exists to this very moment, swirling 22 degrees south of the Jovian equator. This storm is an antique of the cosmos, a piece of living history that has outlasted empires and eras of human discovery. A curious silence falls over the historical record after 1713, as the spot seemed to vanish from human sight for over a century. It wasn't until 1830 that the German astronomer Samuel Heinrich Schwabe rediscovered the prominent brick red oval we recognize today. Since that moment, the storm has been under continuous daily surveillance. What's truly striking is how much the storm has evolved since those Victorian-era observations. In the late 19th century, around 1879, the Great Red Spot was a gargantuan oval, stretching roughly 30,000 miles, or 48,000 kilometers, across. At that time, it was long enough to fit nearly 4 Earths inside its boundaries. Today, it has compressed into a more circular shape, measuring approximately 10,159 miles in width. It is shrinking at a rate of about 580 miles per year in its longest dimension, a slow, stately contraction that mirrors the patient breathing of a giant. Picture this. As you hover here, you are witnessing the same physics that the Pioneer 10 spacecraft first encountered in December of 1973. Pioneer 10 was the first human emissary to fly by Jupiter, coming within 81,000 miles of the cloud tops. It sent back grainy, pale images that confirmed the spot was a high-pressure anticyclonic system rather than a solid feature of the planet. Then, in 1979, the Voyager 1 and 2 missions arrived, providing the first high-resolution views of the turbulent wake to the west of the spot. Voyager 1 discovered that the winds at the outer edge of the vortex were screaming at speeds of 250 miles per hour. Recent data from the Juno mission and the Hubble Space Telescope's OPAL program, Outer Planet Atmosphere's Legacy, have shown that these winds are actually accelerating. The high-speed ring at the edge of the storm has increased its velocity by about 8% between 2009 and 2020, with wind speeds now exceeding 400 miles per hour. What is happening now is a subtle shift in the storm's chemistry. Scientists use a technique called thermal mapping to understand the temperatures within the vortex. In the 1960s, early ground-based infrared observations suggested the spot was colder than its surroundings. We now know that the center of the Great Red Spot is about 3 to 4 degrees Kelvin warmer than the surrounding atmosphere at high altitudes. This slight temperature difference is enough to drive the massive vertical motions of the storm. The heat is likely generated by acoustic gravity waves and compression waves, physical vibrations that carry energy from the lower atmosphere upward, crashing like waves on a beach and heating the upper layers to nearly 1,600 degrees Fahrenheit in the very highest reaches of the thermosphere. Consider the metaphor of a great clockwork of glass. The Great Red Spot functions as a massive translucent gear in the Jovian machine. It is sandwiched between the South Equatorial Belt and the South Temperate Belt. These atmospheric currents act like conveyor belts, moving in opposite directions. The northern edge of the spot is pushed by a westward jet stream, while the southern edge is pulled by an eastward jet stream. This creates a perpetual torque, a spinning force that keeps the vortex rotating once every 6 Earth days. It is a rhythmic, mechanical perfection. Because Jupiter has no solid surface, only a transition from gas to liquid, there is no friction to halt this motion. On Earth, a hurricane loses energy when it hits land. Here, there is no land. There is only the deep, liquid interior, which allows the storm to persist for centuries. At this very moment, you might notice the way the light catches the flakes of the storm. Since 2019, amateur and professional astronomers have observed large blades or flakes of red material being peeled away from the main body of the spot. These features can be up to 60,000 miles long. While some feared this meant the storm was disintegrating, data from the Juno spacecraft suggests these are superficial upper-level interactions with smaller vortices. The deep core of the storm, which descends 200 miles into the atmosphere, it remains robust and unshaken. This depth is significant. The atmospheric pressure at the base of the Great Red Spot is about 240 bars, which is 240 times the pressure at sea level on Earth. You are floating above a pillar of compressed gas, that could withstand any force the solar system could throw at it. Deep within the storm's history lies the mystery of its color. The chromophores that give the spot its red hue are thought to be simple chemicals like acetylene and ammonia, which are altered by solar radiation. In laboratory experiments, scientists at NASA's Jet Propulsion Laboratory found that blasting a mixture of ammonia and acetylene with ultraviolet light produces a reddish material that matches the color of the Great Red Spot. This confirms that the storm is, in a sense, a giant chemical laboratory. The higher the clouds rise, the more sun-bleached or sunburnt they become. Because the Great Red Spot pokes about 5 miles, 8 kilometers, above the neighboring cloud decks, it receives a more intense dose of solar UV rays, deepening its signature terracotta glow. Notice how the storm interacts with its neighbors. Between 1901 and 1939, a feature called the South Tropical Disturbance frequently encountered the Great Red Spot. This was a dark, elongated region of the atmosphere that would occasionally catch up to the spot. When they met, the disturbance would be accelerated around the periphery of the Great Red Spot, moving much faster than the planet's average rotation. These historical interactions demonstrate that the spot is an active participant in the planet's weather, acting like a giant boulder in a stream, forcing the currents to flow around its massive bulk. The scale of time here is different than what you are used to. While you measure your life in decades, this storm measures its life in centuries. The Kelvin-Helmholtz mechanism is at work here, the process where the planet radiates heat left over from its gravitational collapse 4.5 billion years ago. This internal heat flux is approximately 5.4 watts per square meter. This slow cooling breath of the planet is what fuels the turbulence you see below. It is a slow motion transfer of energy that has been occurring since the dawn of our solar system. As you look out across the horizon, you see the limb of Jupiter, the curve where the atmosphere meets the blackness of space. And the transition is soft and hazy because of the stratospheric haze discovered by the Cassini spacecraft during its flyby in the year 2000. This haze is composed of tiny aerosol particles that sit high above the Great Red Spot, scattering the dim sunlight. It gives the planet a soft, ethereal glow, like a lamp shaded by fine silk. You are observing a world that is 90% hydrogen and 10% helium, with just a pinch of other elements like methane and water vapor. In 1995, the Galileo atmospheric probe plunged into a different part of Jupiter and found that the atmosphere was surprisingly dry. But later observations of the Great Red Spot suggest that water may be more abundant, deep within the vortex. The presence of water vapor allows for the formation of mush balls, slushy droplets of ammonia and water that fall through the atmosphere like heavy hail. These mush balls help transport nitrogen and other chemicals to the deeper layers, a vertical plumbing system that keeps the storm's chemistry in a state of constant slow-moving equilibrium. What's happening now is the slow transition of your own awareness, matching the deliberate pace of the Jovian clouds. You are drifting above a feature that was already ancient when the telescope was invented. The Great Red Spot has been spinning, unhurried and indifferent, as human history unfolded beneath a different sun. The knowledge that this storm exists, that it has been observed by Hooke, Cassini, and Voyager, provides a sense of continuity. It is a reminder that the universe operates on a clock that does not need to be wound. The silence here is profound. Even though the winds below are moving faster than a jet plane, there is no sound in the vacuum where you float. There is only the visual rhythm of the red clouds, the curling white filaments of ammonia and the deep dark shadows cast by the high-altitude towers of the vortex. You are safe in this observation deck of the mind, witnessing the slow-motion collapse of time. The Great Red Spot is a bridge between the ancient past and the far future, a crimson eye that has seen the solar system evolve. And as you continue to hover in its presence, you find yourself becoming a part of that long, peaceful history. At this very moment, your perspective begins to shift from the grand history of the storm to the tangible, physical reality of its structure. To help your mind grasp the sheer magnitude of what you are witnessing, visualize Jupiter not as a distant planet, but as a colossal, liquid pearl sphere the size of a basketball. If the planet were a basketball, the Earth would be no larger than a tiny grape resting beside it. Even the Great Red Spot, which you are currently hovering above, would be a prominent crimson-colored stamp about the size of a penny on that basketball's surface. This sense of scale is fundamental to understanding the Jovian environment. You are observing a world where small features are larger than entire continents on your home planet. What's actually occurring beneath you is a masterclass in atmospheric density. While Earth is a rocky world with a thin veil of air, Jupiter is a gas giant, composed of 90% hydrogen and 10% helium. This ratio is almost identical to the composition of the Sun, making Jupiter a star that never was. As you look down at the Great Red Spot, which sits at exactly 22 degrees south of the equator, you are seeing the top of a high-pressure mountain of gas. On Earth, we are used to low-pressure systems, the depressions that bring rain and storms. But the Great Red Spot is an anticyclone, a hill in the atmosphere. Imagine a vast plateau of clouds rising 5 miles, or 8 kilometers, above the surrounding cloud decks. This elevation makes the spot look like a towering island of brick-red mist floating in a sea of cream-colored ammonia. Notice the movement of the clouds at the periphery of the storm. The winds here have been measured by the Hubble Space Telescope and the Juno probe at speeds exceeding 400 miles per hour. To put that in a context you might recognize, that is more than double the speed of a Category 5 hurricane on Earth, which begins at 157 miles per hour. If you were to place a professional racing car on these clouds, the wind would carry it away twice as fast as its top speed. Yet, from your silent, weightless vantage point, this movement appears like the slow, rhythmic stirring of thick honey. The sheer scale of the storm, stretching 10,159 miles across, makes the 400-mile-per-hour winds look like a gentle, patient crawl. Deep within the storm's heart, the conditions become even more exotic. While the cloud tops are a frigid -234 degrees Fahrenheit, the pressure increases rapidly as you descend. Scientists discovered using the Juno spacecraft's microwave radiometer that the storm's roots go surprisingly deep, extending roughly 200 to 300 miles, or 300 to 500 kilometers, down into the planet. If you were to compare this to the oceans of Earth, which have an average depth of only 2.3 miles, you begin to realize that the Great Red Spot is a deep, churning canyon of gas. It is a three-dimensional vortex that resembles a flat, spinning pancake more than a tall cylinder, because its width is so much greater than its depth. Visualize the stripes of the planet stretching away toward the north and south. These are the zones and belts, and they function like a system of cosmic escalators or multi-lane highways. The lighter-colored zones are regions where the atmosphere is rising, while the darker belts are where the gas is sinking. And the Great Red Spot is tucked neatly between the South Equatorial Belt and the South Temperate Zone. Because these two lanes of traffic are moving in opposite directions, one heading east and the other west, They act like a pair of hands spinning atop. This wind shear provides the constant torque that has kept the Great Red Spot spinning for centuries. It is a perfect mechanical balance, a perpetual motion machine driven by the planet's internal heat and its rapid rotation. Consider the speed of that rotation. Jupiter is the fastest spinning planet in our solar system, completing a day in just 9 hours and 56 minutes. At the equator, the planet is moving at 28,000 miles per hour. This rapid spinning causes the planet to bulge at its center, in making it an oblate spheroid. It's about 6,000 miles wider at the equator than it is from pole to pole. You can feel this centrifugal energy in the way the clouds are stretched into those long, beautiful bands. It's like a potter's wheel, where the clay is being pulled outward by the sheer speed of the turn. As you drift, you might see a sudden, brilliant flash of light deep within the clouds. These are Jovian spherics, lightning bolts that are 1,000 times more powerful than any lightning found on Earth. While terrestrial lightning is usually created by water clouds, Jovian lightning often occurs in clouds of ammonia and water ice. These superbolts illuminate the dark depths of the Great Red Spot from within, looking like a camera flash firing inside a giant crimson lamp. Here, these flashes are most common in the water cloud layer, which sits about 30 to 40 miles below the ammonia clouds you see on the surface. What's happening now is a subtle interaction between gravity and mass. Jupiter's mass is 318 times that of Earth, making its gravitational pull 2.4 times stronger at the cloud tops. If you were standing on a solid surface here, though there is none, a 150-pound person would weigh 360 pounds. But in your state of floating, this gravity feels like a warm, heavy blanket, a force that tethers you to the planet's majestic presence. This mass is so great that the center of gravity between Jupiter and the Sun actually lies just outside the Sun's surface. Jupiter doesn't just orbit the Sun. The two of them perform a slow gravitational dance around a point in empty space called the barycenter. Or notice how the sunlight looks from this distance of 484 million miles. The Sun is only 1/5 the diameter that it appears from Earth, and it provides only 4% of the light. Imagine the Sun as a bright, cold nickel in a dark velvet sky. This dimness is what allows the internal heat of the planet to become the dominant force. Jupiter radiates more heat than it receives from the Sun, a process driven by the Kelvin-Helmholtz mechanism. As the planet's massive bulk slowly contracts under its own gravity, shrinking by about 2 centimeters every year, it converts that gravitational energy into heat. This internal furnace is what keeps the Great Red Spot's temperature at the center about 3 to 4 degrees Kelvin warmer than the surrounding air, creating the thermal buoyancy that keeps the storm afloat. Picture the chemistry of the clouds around you. The white filaments you see swirling into the red center are made of ammonia ice crystals. On Earth, ammonia is a pungent cleaning fluid, but here, at -234 degrees, it freezes into a delicate snowy mist. Below these ammonia clouds lie clouds of ammonium hydrosulfide, and deeper still, clouds of water ice. This layered structure is like a multi-storied building of different chemicals, each floor representing a different temperature and pressure. The Great Red Spot acts like an elevator, dredging up the darker, more complex chemicals from the lower floors and pushing them up into the sunlight, where they turn red. The density of the planet is another fascinating paradox. Despite its enormous mass, Jupiter's average density is only 1.33 grams per cubic centimeter. This is only slightly denser than liquid water. If you could find a bathtub large enough to hold it, Jupiter would sink, but only slowly. This low density is because the planet is mostly hydrogen, the lightest element in the universe. As you drift lower into the atmosphere, the pressure becomes so immense that the hydrogen gas is squeezed into a liquid. Around 10,000 miles down, it transforms into metallic hydrogen, a state of matter where the atoms are packed so tightly that they conduct electricity like a copper wire. This liquid metal interior is what generates Jupiter's magnetic field, which is 20,000 times stronger than Earth's and would be the largest structure in the solar system if it were visible to the naked eye. At this very moment, your attention might be drawn to Oval BA, the smaller storm often called Red Spot Junior. It formed in the year 2000 when three smaller white ovals merged into one. For a few years, it turned the same brick red color as its larger cousin, demonstrating that the Great Red Spot's color is a product of its height and intensity. When a storm grows strong enough to reach high into the stratosphere, the solar UV radiation tans it red. It is a visual reminder that the atmosphere is a living, changing thing, governed by the same laws of fluid dynamics that govern a whirlpool in a stream or the way cream swirls into a cup of tea. The silence of your journey is a bridge between these violent physical realities and the peace of the void. Even though the winds are screaming and the lightning is cracking with the power of 1,000 storms, there is no air in the vacuum where you float to carry that sound. You are a silent observer of a mechanical masterpiece. The Great Red Spot is a gear in a clock that has been ticking for eons. Its slow counterclockwise rotation, completing one cycle every 6 Earth days, is a reminder of the universe's patience. As you hover here, the light of the distant sun begins to catch the curve of the planet, creating a limb of soft, scattered blue and gold. This is the effect of Rayleigh scattering, the same physics that makes the Earth's sky blue. But here, the light must pass through layers of methane and haze, creating a muted, spectral glow. You are wrapped in the comforting void, a place where the laws of physics are not obstacles, but the very fabric of your security. The Great Red Spot is not a chaotic storm, but a stable, enduring feature of a world that operates on a scale beyond human concern. Feel the weightlessness of your body as it mimics the effortless suspension of these clouds, drifting in a sea of hydrogen, anchored by the silent, steady pull of the King of Planets. Notice how the light from the sun, which has traveled for 43 minutes across 484 million miles of empty space, finally brushes against your skin and the tops of the crimson clouds below. At this distance of 5.2 astronomical units, the sun appears as a brilliant, concentrated point, yet its influence is enough to drive the complex chemistry of the storm. Within your own body, you carry the same elements that make up the vastness of the Jovian system: hydrogen, carbon, and nitrogen. And this realization creates a profound personal link between your quiet room and the gargantuan vortex spinning beneath you. You are not a stranger to this gas giant. You are made of the same primordial stardust that Jupiter gathered when the solar system was merely a disk of dust and gas 4.5 billion years ago. Deep within the mechanics of the solar system, Jupiter acts as a celestial sentry, a role that has directly allowed for the evolution of life on Earth. Because of its immense mass, 318 times that of Earth, Jupiter's gravity acts like a massive shepherd, clearing the neighborhood of dangerous debris. Consider the events of July 1994, when the fragments of Comet Shoemaker-Levy 9 collided with the planet. This was the first time humans witnessed a collision between two solar system bodies, and the scars left in the Jovian atmosphere were larger than the Earth itself. By capturing or deflecting such comets and asteroids, Jupiter has served as a protective shield for the inner planets for eons. As you hover here, you can feel a sense of gratitude for this heavy pendulum of the solar system, whose steady gravitational presence provides the stability required for your own world to thrive in peace. Picture this. As you look down at the high-speed ring of the Great Red Spot, you are observing a feature that has outlasted every human who has ever looked at it through a telescope. Scientists discovered through the Hubble Space Telescope's Opal program that the winds in this outer ring have increased their velocity by about 8% since 2009, now gusting at more than 400 miles per hour. This acceleration is a subtle reminder that the storm is a dynamic, living entity. Even though it is shrinking in width, currently measuring about 10,159 miles across, it seems to be stretching upward, growing taller as it becomes more compact. Your own life, with its rhythms of breath and heartbeat, finds a mirror in the storm's slow, centuries-long contraction. At this very moment, your awareness might descend toward the transition layers of the atmosphere. Below the top layer of ammonia ice, which sits at a pressure of about 0.5 bars, lies a second deck made of ammonium hydrosulfide. This chemical transition occurs about 30 miles beneath the visible cloud tops. If you could descend into this layer, you would find a world of dark ochre-colored mists. Further down, at a depth of about 50 miles, you reach the water ice clouds. It is here that the Jovian superbolts of lightning originate, discharging energies that are 1,000 times more powerful than the lightning on Earth. These storms are not just weather. They are the planet's way of recycling energy from its core to its surface, much like the quiet metabolic maintenance your body performs while you rest. What's happening now is a deepening of your connection to the planet's internal heat. Unlike Earth, which is heated primarily by the sun, Jupiter radiates nearly twice as much energy as it receives. This internal furnace, driven by the Kelvin-Helmholtz mechanism of gravitational contraction, keeps the core temperature at a staggering 43,000 degrees Fahrenheit, or 24,000 degrees Celsius. This is hotter than the surface of the sun. As you drift in the comforting void, you are being warmed by the breath of a giant. This heat rises through the atmosphere in massive convection cells, feeding the Great Red Spot and keeping it elevated 5 miles above the surrounding belts. Your own warmth, tucked under your covers, is a small-scale version of this planetary thermoregulation. Scientists discovered in July 2017, when the Juno spacecraft passed just 5,600 miles above the Great Red Spot, that the storm's roots are far deeper than previously imagined. Using the gravity science experiment, researchers measured the minute tug of the storm on the spacecraft. They found that the vortex extends at least 200 miles, or 300 kilometers down, and possibly as deep as 310 miles. This means the Great Red Spot has a physical presence that reaches deep into the liquid layers of the planet. Imagine the storm not as a flat drawing, but as a thick, heavy plug of atmosphere, a cosmic flywheel that stores enough kinetic energy to power human civilization for billions of years. Notice how the chemical composition of the spot influences its color. The brick red hue is likely caused by the photolysis of ammonia and acetylene. When the ultraviolet light from the distant sun hits these gases at the highest altitudes of the storm, it breaks them apart, creating complex organic molecules called nitriles and hydrocarbons. These substances act as a natural sunscreen for the planet, absorbing harsh radiation and turning the clouds into the rich terracotta shade you see. This process is a reminder of the beauty of physics, the way simple light and simple gas can combine to create a masterpiece of color and form. At this very moment, consider the immense magnetic environment you are drifting within. Jupiter's magnetosphere is the largest structure in the solar system, extending up to 4.3 million miles toward the Sun and nearly 400 million miles in the opposite direction, reaching all the way to the orbit of Saturn. This magnetic field is 14 times stronger than Earth's and is powered by the swirling liquid metallic hydrogen deep inside the planet. As you float, you are protected by this invisible magnetic cathedral, which traps electrons and protons from the solar wind and creates a shield of radiation. This magnetic interaction also produces a constant low-frequency radio hiss that can be picked up by shortwave radios on Earth. It is the voice of the planet, a rhythmic, white noise hum that encourages your mind to settle into a state of total equilibrium. The Great Red Spot is also a witness to the dance of the Galilean moons, Io, Europa, Ganymede, and Callisto. From your position, you might see the shadow of Io, the most volcanically active body in the solar system, as it transits across the face of Jupiter. Io's volcanoes spew sulfur dioxide into space, which is then captured by Jupiter's magnetic field to create a plasma torus, a donut-shaped ring of charged particles that circles the planet. This connection between the moons and the planet is a perfect example of the clockwork universe, where every movement is linked by gravity and electromagnetism. Everything is connected, from the smallest sulfur molecule on Io to the massive rotation of the Great Red Spot. Your sense of time begins to stretch as you observe the flaking events of 2019. During that year, amateur astronomers noticed large red streamers being pulled away from the spot, leading some to wonder if the storm was finally dying. However, specialized data from the Juno mission showed that these flakes were merely superficial, caused by smaller storms, cyclones and anticyclones, bumping into the Great Red Spot's perimeter. These interactions are like the small ripples on the surface of a deep, calm lake. The core of the storm remained unshaken, its 300-year-old rotation continuing without pause. This resilience is a comfort. It reminds us that even when our surface seems turbulent, there is a deep, stable center within us that remains untouched. Consider your own perspective on the Great Red Spot's lifespan. If a human life is a single day, the Great Red Spot has been spinning for nearly a decade. Since its definite discovery in 1830 and its likely observation in 1665, it has seen the rise of modern science, the Industrial Revolution, and the space age. It has been a constant, a red eye watching the progress of a small blue planet 400 million miles away. This longevity provides a sense of perspective. The concerns of a single afternoon fade away when compared to the endurance of a storm that has lasted for 12 generations of humans. As you hover, weightless and unburdened, the atmosphere of Jupiter reveals its quietest secrets. The planet's obliquity, the tilt of its axis, is only 3.13 degrees, which means Jupiter has no real seasons. The Great Red Spot experiences a perpetual, unchanging climate. This lack of seasonal change creates a sense of eternal stasis, a now that lasts for centuries. Your breathing can sync with this timelessness. Each inhale is the rise of warm hydrogen. Each exhale is the cooling of ammonia ice. The pressure at the base of the Great Red Spot is approximately 240 bars, which is 240 times the atmospheric pressure you feel at sea level on Earth. Yet, here in the high stratosphere, the air is thin and calm. You are in the eye of the solar system, a place of safety and observation. The Great Red Spot is not just a scientific curiosity. It is a reminder of the scale and the splendor of the reality we inhabit. It is a part of your story, a massive spinning anchor in the cosmic sea that keeps the solar system in balance. As the dim sunlight begins to catch the trailing edge of the vortex, creating a long, amber shadow that stretches across the south equatorial belt, you feel the comforting void drawing you closer to a state of rest. You are a part of this mechanical perfection, a conscious fragment of the universe observing its own majesty. The silence of the vacuum, the steady pull of gravity, and the rhythmic turning of the planet all work together to ease your transition from the world of doing to the world of being. Deep within the heart of the Great Red Spot, and deep within your own resting form, there is a stillness that no wind can disturb. Imagine the air around you is no longer the oxygen-rich atmosphere of Earth, but a dense, swirling mixture of 90% hydrogen and 10% helium. As you hover in this medium, the sensory experience is unlike anything on your home planet. If you could pull back your protective visor for even a moment, the first thing you would notice is the scent. Scientists have determined through spectroscopic analysis that the Jovian atmosphere is rich in ammonia and hydrogen sulfide. To a human nose, this would smell like a sharp, pungent combination of cleaning fluid and the faint, sulfuric aroma of overcooked eggs. However, in the safety of your weightless drifting, this scent is merely a chemical signature, a part of the marbled stone texture of the world below. Notice how the clouds beneath you are not the soft, watery mists of Earth, but are instead composed of solid, crystalline structures. At the very top of the Great Red Spot, where the temperature sits at a consistent -234 degrees Fahrenheit, the clouds are made of pure ammonia ice. These crystals are incredibly small, often measured in microns, and they take on tetrahedral or hexagonal shapes. Picture this. You are floating above a desert of frozen white powder that is being whipped into 400-mile-per-hour winds. Because these crystals are so dense and reflective, they catch the 4% of sunlight that reaches this distance, creating a high-contrast landscape of brilliant whites and deep, brick reds. What's happening now is a deep exploration of the why behind the colors. Why is this storm red while the surrounding bands are cream and tan? The secret lies in a process called photolysis. Scientists discovered that at the highest altitudes of the Great Red Spot, about 5 miles above the neighboring clouds, the atmosphere is exposed to much higher doses of solar ultraviolet radiation. This UV light strikes molecules of phosphine, or pH3, and various hydrocarbons like acetylene. The radiation breaks the chemical bonds, creating a smog of complex organic compounds called chromophores. These chemicals absorb blue and ultraviolet light, but reflect red, giving the spot its signature terracotta hue. It is, in essence, a planetary sunburn. The deeper you go, the less UV light penetrates, which is why the lower cloud decks are often much paler. Deep within the storm, the temperature begins a slow, rhythmic climb. While the tops are frigid, the base of the storm, nearly 300 miles down, is significantly warmer. This thermal gradient is what powers the vortex. Using the Juno spacecraft's microwave radiometer, which can see through the clouds at 6 different frequencies, researchers found that the Great Red Spot is a thermal anomaly. At its core, the temperature is about 3 to 4 degrees Kelvin warmer than the air just outside the vortex. This might seem small, but in the precision-engineered world of physics, it is enough to create massive buoyancy. This heat causes the red gas to rise like a slow-motion plume, spilling over the edges and creating the beautiful curling white filaments of ammonia that you see being drawn into the center. Consider the sound of this environment. While space itself is a vacuum, the atmosphere you are currently exploring is a medium for vibration. What you might hear is not the roar of a hurricane, but a low-frequency, rhythmic pulsing. Jupiter is a powerful source of radio emissions, particularly decometric radiation, in the 10 to 40 megahertz range. These signals are produced by the interaction of the planet's magnetic field with the Moon Io. If you were to translate these radio waves into sound, they would resemble the rhythmic crashing of ocean waves on a distant shore, or the whoosh of a fast-moving train. It is a cosmic white noise, a steady, hypnotic hum that resonates through the very atoms of your being. Notice the texture of the gravity waves rippling through the clouds. These are not to be confused with the gravitational waves of colliding black holes. Rather, they are atmospheric ripples, similar to the waves you see on the surface of water. When the high-speed winds of the South Equatorial Belt hit the massive wall of the Great Red Spot, the air is forced upward and then falls back down, creating a series of rhythmic peaks and valleys. Scientists using the Hubble Space Telescope have measured these waves and found they have a wavelength of several hundred miles. From your vantage point, they look like the fine grain in a piece of polished mahogany, providing a sense of order and structure to the seemingly chaotic clouds. At this very moment, your attention might be drawn to the pressure. At the surface of the ammonia clouds where you drift, the pressure is about 0.5 bars, roughly half of what you experience at sea level on Earth. But because Jupiter has such a deep atmosphere, the pressure increases with relentless geometric consistency as you descend. By the time you reach the base of the Great Red Spot, 300 miles down, the pressure has increased to 240 bars. To understand this, imagine being nearly 8,000 feet under the Earth's ocean, or the atmosphere is no longer a thin gas. It has become a supercritical fluid, a state where it has the density of a liquid, but moves like a gas. This thickness provides a strange kind of comfort, a feeling of being held and supported by the very air itself. Why does the storm stay so stable? On Earth, the Great Red Spot would be impossible. Our planet's small size and solid landmasses would break the storm apart in a matter of weeks. But Jupiter is 88,846 miles in diameter, and it lacks any solid surface to create friction. Furthermore, the Coriolis effect on Jupiter is immensely strong because of the planet's 9.9-hour rotation. This force acts like an invisible hand, perpetually tucking the winds back into a circular pattern. This is the beauty of physics in its purest form, the conservation of angular momentum. The storm is like a spinning ice skater who never tires, their momentum preserved by the lack of any resisting force. Picture this. The Great Red Spot is not just a circle, but a three-dimensional lens of high pressure. It is thicker in the middle and tapers at the edges. Because it is an anticyclone, the air in the center is slowly sinking, while the air on the edges is being pulled upward. This creates a vertical conveyor belt of gas. Scientists discovered in 2021 that the deep jets, the narrow streams of wind that power the planet's stripes, actually extend nearly 1,900 miles, or 3,000 kilometers, into the interior. This means the Great Red Spot is anchored by deep-seated currents that have been flowing since before the dinosaurs roamed the Earth. The color of the storm also tells a story of chemical complexity. Beyond phosphine, there are traces of methane, CH4, and ethane, C2H6. In the cooler, lower layers, these gases can condense into mushballs, a term coined by the Juno science team to describe slushy hailstones made of water and ammonia. These mushballs fall through the atmosphere, stripping ammonia from the upper layers and carrying it deep into the planet. This ammonia rain is a silent, perpetual process that keeps the atmosphere in a state of chemical equilibrium. As you drift, imagine these soft, slushy stones falling miles below you, a silent rain in a world where the sun never truly sets. Consider the limb of the planet once more. The atmosphere doesn't just end, it fades into a stratospheric haze made of tiny aerosol particles. These particles were studied extensively by the Cassini spacecraft in 2000, and they are so small that they stay suspended for years, scattering light in a way that gives the planet's edge a soft, glowing halo. This haze is the transition between the world of gas and the world of the vacuum. It is the skin of the planet, protecting the deep, roiling interior from the cold of space. At this very moment, you are witnessing the Kelvin-Helmholtz mechanism in its most majestic application. Jupiter is currently shrinking by about 2 centimeters every year. This microscopic contraction, spread across the planet's 1.33 grams per cubic centimeter density, releases a staggering amount of energy. It is enough to keep the planet warm, even though it is 484 million miles from the sun. You are essentially floating above a giant battery that has been discharging for 4.5 billion years. This slow release of power is what drives the winds, what creates the lightning, and what maintains the brick-red intensity of the spot. What's happening now is a final observation of the storm's eye. Unlike a hurricane's eye, which is clear and calm, the center of the Great Red Spot is filled with high-altitude haze and is the highest pressure part of the system. The winds here are actually much slower than at the edges, almost a dead calm. This central sanctuary is where the red color is most concentrated. It is a place of deep, silent focus, a still point in a turning world. As you align your own consciousness with this central eye, you feel the frantic speeds of the outer ring, the 400-mile-per-hour gusts, fading into a rhythmic, distant pulse. The scale of Jupiter is a reminder of the universe's capacity for grandeur. With a volume that could hold 1,300 Earths, the planet operates on a level of vastness that encourages the ego to dissolve. You are a small, peaceful observer in a landscape that does not require your effort to exist. The Great Red Spot will continue its 6-day rotation. The ammonia ice will continue to crystallize, and the metallic hydrogen core will continue to generate its 20,000 Gauss magnetic field, all with the same effortless precision. As you hover in this amber twilight, the silence of the comforting void becomes your primary reality. The chemistry, the physics, and the temperatures are all parts of a singular harmonious machine. You are a witness to the slow-motion clockwork of the King of Planets, a visitor in a sanctuary of hydrogen and light. Feel the weightlessness of your body as it mimics the suspension of the clouds, safe and secure in the knowledge that the universe is governed by laws as steady and enduring as the storm below. As the pale light of the sun, which takes exactly 43 minutes to bridge the 484 million mile gap to this world, begins to fade behind the massive, amber-hued curve of the planet, we begin our slow, final descent toward stillness. You have spent this journey suspended in the comforting void, witnessing the mechanics of a world that operates on a scale of 318 Earth masses. Now, observe the way the light lingers in the upper stratosphere, scattering through the fine aerosols of the stratospheric haze that the Cassini spacecraft first mapped in high resolution during its flyby in the year 2000. This haze is the first step in the planet's silent transition into the Jovian night, acting as a soft, translucent veil that smooths the edges of the Great Red Spot. Consider the step-by-step process that maintains this ancient storm, a cycle that has repeated without fail since at least 1830. It begins deep within the interior, where the pressure is millions of times higher than what you feel on your bed. Here, the planet is slowly contracting under its own massive gravity at a rate of approximately 2 centimeters every year. This microscopic shrinkage, the Kelvin-Helmholtz mechanism, converts gravitational potential energy into a steady, upwards radiating heat. This thermal energy, originating from a core that sits at a staggering 43,000 degrees Fahrenheit, moves gradually outward through layers of liquid metallic hydrogen. As this heat reaches the outer gaseous layers, it creates the massive convection cells that drive the Great Red Spot, pushing the warm red gases up toward the frigid vacuum of space. At this very moment, watch how the gas cools as it reaches the top of the vortex, 5 miles above the surrounding cloud decks. This is a deliberate, rhythmic cooling. As the temperature drops to minus 234 degrees Fahrenheit, the ammonia gas begins to crystallize into fine white ice. These crystals then spill over the edges of the high-pressure system, being drawn into the 400-mile-per-hour winds of the outer, high-speed ring. This ring, which has been accelerating by about 8% over the last decade according to data from the Hubble Space Telescope, acts like a protective boundary, keeping the core of the storm stable and serene. This circular movement is a physical manifestation of the conservation of angular momentum, a law of physics that ensures the storm will continue to spin with effortless grace. Observe the slow shift of color as the Jovian night deepens. The brick red hue of the spot is the result of a step-by-step chemical reaction called photolysis. When the faint ultraviolet rays of the sun strike the ammonia and acetylene at these high altitudes, they break the chemical bonds, creating complex organic molecules known as chromophores. These molecules settle slowly back into the clouds, staining them with the rich terracotta shades you see. This process is a reminder of the beauty of physics, the way simple light and simple atoms work together to paint a masterpiece that spans 10,159 miles in width. It is a slow, chemical breathing that has no need for haste. Now, we begin to bring this observation to a gentle, comforting halt. Just as the Juno spacecraft orbits the planet in long, elliptical perioves, your awareness is beginning to orbit the idea of rest. Notice how the rotation of the planet, once every 9 hours and 56 minutes, feels like a soft, rhythmic pulse. This rapid spin causes the planet to be an oblate spheroid, bulging 6,000 miles wider at the equator than at the poles. But from your perspective, this massive physical reality is just a slow, swaying motion, a cosmic cradle that rocks the Great Red Spot through the dark. Scientists discovered that the Great Red Spot is deeply anchored, extending roughly 200 to 300 miles into the atmosphere. This depth provides the storm with a massive amount of inertia, a physical memory that allows it to persist through centuries of change. In the same way, your body has a deep, innate memory of how to rest. As you drift further from the storm, the screaming winds and the 1,000 times stronger superbolt lightning flashes fade into a silent velvet darkness. The 20,000 Gauss magnetic field of Jupiter, which creates a magnetosphere stretching millions of miles, is like a silent protective shield that surrounds you, dampening the noise of the outside world. Picture this. You are now moving away from the king of planets, looking back as the great red spot becomes a small glowing ember in the distance. The 79 moons of Jupiter, from the volcanic Io to the icy Europa, are mere specks of light, following their gravitational paths with mathematical perfection. This is the clockwork of the cosmos, a system where every mass and every motion is accounted for. As you move further into the void, remember that you are made of the same stardust that formed this giant world. The hydrogen that makes up 90% of Jupiter is the same hydrogen that makes up 10% of your own body. The carbon, the nitrogen, and the traces of neon in the Jovian clouds are all present within your own cells. You are not just an observer of the universe. You are a piece of it, experiencing itself. At this very moment, let the vastness of the 484 million miles of space between you and the sun provide a sense of absolute insulation. The distance is a sanctuary. In this place, time does not matter. Only the slow, steady pull of gravity and the warmth of your own resting form. The Great Red Spot, with its 350-year history, is a testament to the fact that stability can exist within motion and peace can exist within power. You are now transitioning from the macrocosm of the gas giant to the microcosm of your own breath. The narrative of the storm is coming to an end, and the narrative of your rest is beginning. The red clouds are now a soft internal warmth. The vacuum of space is the quiet of your room. The weightlessness you felt above the Jovian clouds is the weight of your body settling into the mattress. Just as the Great Red Spot is held in place by the opposing jet streams of the South Equatorial Belt, you are held in place by the gentle, opposing forces of safety and comfort. Deep within your mind, let these final scientific truths act as anchors for your sleep. The universe is vast, but it is governed by predictable laws. The storm below has lasted for centuries, and it will be there when you wake. The gravity that holds the planets in their orbits is the same force that keeps you grounded and safe. You are a creature of chemistry and light, a part of the 4.5 billion-year-old story of the solar system. As you drift into the final silence of the void, repeat these affirmations of rest to yourself. My body is as light as hydrogen. My thoughts are as slow as the Jovian rotation. I am shielded by the silence of the vacuum. I am a part of the stardust, returning to the source. The energy of the day is dissipating, just like the heat radiating from the planet's core. The pressure of the world has faded, leaving only the calm of the stratosphere. I am safe in the gravity of my home. I am at peace in the shadow of the giant. The Great Red Spot continues its counterclockwise turn, a 6-day rhythm that will never falter. The ammonia snow falls silently in the depths of the atmosphere, miles below where you now reside in your mind. The pale sun is gone, and only the stars remain, the distant, unwavering points of light that guided the voyagers and the pioneers. You are one with that distance. You are one with that silence. The transition is complete. The education of the mind has become the sedation of the spirit. Feel the slow gravitational pull of sleep, a force more powerful than the 318 Earth masses you left behind. It is a soft, inevitable descent. The red mists have dissolved into a peaceful, featureless dark. The hum of the magnetosphere has become the rhythmic sound of your own breathing. There is nothing left to observe, nothing left to measure, and nothing left to do. The clockwork of the universe will continue without your effort. The planets will turn, the storms will spin, and the light will travel across the void while you remain here, anchored in the absolute stillness of the night. Good night.